Hey everybody, how's it going? I'm sorry for delaying this a little bit. I got caught up in something. So last time we made some functions that could do a simple linear regression. So we have a predictor given some slopes and a slope and an intercept value. We can make a point there. We can do the MSE. We can look at the mean squared error, which says numerically how good or bad our model is. And we have train params, which says given these x and these y's and some parameter values that I'll just set as like nothing at first. It's some dictionary that looks like this. It's going to train, so change beta naught and beta 1 so that we have the values that minimize the MSE for the x's and the y's. Okay, it minimizes that function for that given data. Today we're going to look at something a little bit different, but so that we can really do this is generate data. Okay, we need to be able to understand kind of where the data comes from, maybe not down to the exact statistical format you would see in a book, but we want to be able to make the data that follows this type of pattern, which is, two variables. We have an x and a y, and the y follows the pattern of the x's in some linear format. As x increases, y either linearly increases or y linearly decreases. We want to make this function so that we generate this data for an arbitrary amount of them, so say 10 xy pairs, 20 xy pairs, whatever, and that way we really understand what's going on here, and we can easily test our models on it. Okay, so to do this, we are first going to open or import random from Python, okay, just for random numbers. And why do we need random numbers? Well, let me talk about this right now. So if we have, say, this isn't going to be the function, I'm just going to show you this for now. If we have, say, 4 different values, x equals the list of 1, 2, 3, and 4. Well, we want some linear relationship for y. So that means something like a beta naught, which I'll do like this for now. I know that this isn't proper syntax, it's just showing you. We need something like y is equal to beta naught plus beta 1 times 1. That would be the first value. And then the second one would be beta naught plus beta 1 times 2 times 2. And then and so on. Each of those values for 3 and 4 would be basically the same, but with 3 and 4 there. Except that would draw a perfect line. Okay, and let me show you that with, if I was to pick, say, beta naught, set beta naught equal to, say, 2 right now, and beta 1, set that equal to, say, 3. Okay, so if we were really running this, and let me just copy and paste this, so I actually have all of the data there. So it's the same, except this is 3, and this is 4. Now, x and y, well, it's kind of tough to see what it looks like without a graphing library, so I'm going to import one more library in this lecture. That's going to be matplotlib.pyplot as plt. Okay, don't worry about the specifics of this, just this is what it looks like. So we can use this thing's plot function. We can call plt.plot and then x and y. And what that does is this draws a line, except just to really prove to you that it's a line, we have, if you do scatter, that is going to make it a scatter plot, which just means plot the x and the y values as points. And so this is the x, this is the y, and these are the points which fall in a perfect line. But that's not really true in reality. Okay, yes, we could have technically made this our random function, our data generating function, except it doesn't really make sense, because if you were to go into the real world, it's not going to be perfectly in a line like this. There's so many external factors that we don't expect. It's just, you can think about kind of rolling the die every single time we get a y value for an x. It's not gonna, there's some probability here and an error where we're messing up the y value. Even though it has this underlying relationship, there's going to be what we call noise in the data. Okay, so it's actually not going to look quite like this. It's going to look, maybe this was a little bit higher, a little bit lower. This was a little bit higher, a little bit lower, and so on. Each of these things are not, the y values aren't quite exactly form this line here. So the reason we need random is because we want to add some random value, and I'll just call it random for now, even though this isn't correct syntax quite yet. We want to add some random number here into each of them. So that way, and sorry, I'm running out of room here, random I'll just put it down here. So we want to add a random number to each of these y values because that's what's going to really move these things around a little bit. Either if it's a positive number, it'll lift it up a bit, negative, it'll lift it down a little bit. And to do this, let me just show you the function, which is random.uniform, which isn't statistically correct. I will note that technically it's called it's a normal distribution, which we'll look at later. But if we look at a normal or a uniform for now, we call it like this, which just says left is the lower bound and right is the upper bound, where it's going to produce a value between these two numbers. And it turns out for uniform, it means that the probability of any single value in this valid range of -1 to 1 has an equal probability of being selected, except we'll see later that's not really true, but this is totally fine right now to use uniform. Okay, so just to run this a few times, we'll see we're going to get both negative and positive values between -1 and 1. So we can use this each time. And so instead, if we put it here, sorry, I just screwed up because I got rid of it. If I get it back over here, plus random.uniform every single time, and I will just put the list like this so we can see it very well. If I add the uniform every single time, then instead, when I plot the points, you can see it's not really that perfect of a line anymore. If I was to draw a line, it would go more like this, and this point wouldn't fit that well. Or if I was to do it again, that one looks like a fair amount of a line. But so maybe instead we'll do -2, -2, -2, and maybe 2, 2, 2, 2. So now we can see it's still kind of a line, except it's not perfectly right. And we could play around with this value depending on what we really wanted. I'm going to stick with -1 and 1 for our example. Okay, so now that we understand what we're trying to do, in the next video, I'm going to turn this into a function, and I will see you then.